Hello everyone. Today we are going to talk about one of the most important issues that many of the new teams struggle with. Typically, in the World Robotics League, First Lego League, World Robotics Olympiad, and many other competitive robotics, the mission completion is time bound. Robot starts it at base, and the missions are distributed all over the robot work area. Some are closer, some are farther from the robot base, and depending on the complexity, different missions have different score. Quite often, the newer teams struggle with this strategy, how to organize or how to come up with a proper robot mission planning so that they can optimize their effort to get the maximum score. So what is referred to as path planning or process planning is I'm going to explain in this video here and suggest few strategies that will help you maximize the total score. So some of the important considerations. First, farther the robot travels, more the drift. We are going to talk about the drift issue a little bit later. Second, valuable time is lost in traveling. So as the robot is traveling, you are not actually collecting the score. It is just when the robot reaches to the mission, completes the mission, that is when you actually get the score points. Third, robot may reach to its destined point. However, it is very important that the robot is properly oriented with respect to the mission to engage with the mission and complete the task. So what we would like to suggest is you may collect the score for highly certain closer mission one at a time, or you may combine multiple missions which are placed far from each other because you have already spent so much time in traveling. So let's explain the idea pictorially. So as you can see, the top robot is an EV3 based robot, and the robot here is the Spike Prime robot. So as the robot starts from its initial point and travels, because of the drift, the robot may not only move from its intended point, its orientation may also change. So one of the strategies, as we discussed earlier, what you can do is the robot starts from its base position. It may go at very fast speed to the missions which are placed very close to the robot base, and the robot can afford to travel multiple times because the missions are closer, but robot can go at a faster speed. Also, since the missions are closer, the drift and the inaccuracies will be minimized. So the robot travels fast, completes the mission 1, comes back, robot completes the mission 2, comes back, robot completes the mission 3 and comes back. So we leave it up to you to determine how far, like what is the distance that you would like to consider the closer missions and what distance you would like to consider for a mission to be a farther mission. So as you can see in the picture on the right hand side, if the robot has to travel far, it spends significant amount of time in traveling to the farther missions. So it doesn't make sense for the robot to come back and forth. What you may do is you may combine the three missions. Another very useful strategy is divide and conquer. That is, in divide and conquer approach, you may divide the missions depending on the proximity. So say for example, there are multiple missions in this area. So you can assign this as one of the zones, zone 4 here, or zone 5, zone 3, zone 2. The robot may reach to uh, the key point within that zone, attempt various missions in that zone, and it can either return to the base or it can move to the next zone and attempt the missions there. Few other very valuable inputs. As much as the mission completion is important, or creativity in design or programming to complete the mission is important. Be very creative about reducing the overall errors. It may so happen that out of 10 times, 2 times your robot works perfectly all right, but 8 times robot is not able to complete the mission. That's something to be concerned about. So be creative about reducing the errors so that you can complete the mission with high degree of certainty. Next, the order in which you run the robot or the order in which you complete the mission. Go from more certain to less certain. This is something that many teams do not pay attention to and lose very valuable time. When the robot is traveling, you are not collecting any score. Actually, when robot completes the mission, that is when you collect the score. So you may travel slow towards the mission to reduce the drift or reduce the error, but as soon as the mission is completed and you have to return to the base, return as fast as you can. Another very valuable input. It is the overall score that matters. In case the robot has traveled very far and it will take significant amount of time to return to the base. It may travel straight, it may take multiple turns before it reaches to the base. So very valuable time is lost just for the robot to travel. And if you have a mission that you are planning to attempt after that run and that results in a higher score, do not hesitate in taking penalty and picking up the robot. Another very valuable input. Think, think, think your strategy. You may run small missions that have high certainty and accumulate smaller points towards overall a large score instead of relying on a large complex mission at a risk of lower certainty. Another very valuable suggestion, run your robot on multiple tables. You can talk to other teams. You may let them use your table and you can request them to use their table so that you can perfect your robot in different kind of settings. Because believe me, most of the time there will be some degree of variation in the table that will be available in the field for your robot to run. Thank you. I hope you find this video useful. Please subscribe for more information videos.